In this chapter, we were going to talk about the application of logarithm function and the application function model. So, first one. Here is one example. The Bismuth 210 is an asymptote that decays by about 13% each day. What is the half-life of bismuth? So the first concept is, what is half-life? Well, half-life, by definition, means a radioactive isotope is the time it takes for half of the substance to decay. So, for example, I have an asymptote. It starts with 100 milligrams. So, half-life is how long does it take for this substance to decay to 50 milligrams. So, this is called half-life of that specific substance. We are finding the time. How long does it take? So such as you take 2 days to decay from 100 milligram to 100 milligram to 50 milligram. So I would say, okay, so the half-life of that substance is 2 days. If it takes 100 days, I would say, okay, the half-life of this substance is 100 days. So now let's take a look at our example. So the Bismuth 210 is an asymptote that decays about 13% each day. What is the half-life of the bismuth? Well, the first is we need to know this is an exponential growth or exponential decay. So, exponential growth function or decay function should be fx, the output, equals to the input times 1 plus or minus, depends on if it's growth or decay. Since this is a decay, so it's going to be subtract the rate, and this is going to be to the time power. Okay, so they ask you what is the half-life of bismuth, and I know that, okay, the input is A, so the output, if you half of it, it's going to be half A, right? So the setup of the function should be this one, and the rate is 13% per day, so that means we minus 0.13 into T. Okay, since they both have A, I can cancel out 8. So I have 1/2 equals to 0.87 to T. So if the unknown variable is in the exponential position, so that means we need to use a logarithm to solve it. You can exponentiate the function on both sides, or you can convert these to exponential function. Well, let's convert this. So I have log, the base is still 0.87, input become output, output become input. So this is equal to T. Now let's use a decimal or other calculator to calculate that. So usually I use Google Calculator. This time I want to show you how to calculate this with a decimal. So now on the left side of the screen, we have our decimal calculator. We just need to have log. Remember the change base property, 1/2. I use common log divided by log 0.87. So I'll get the answer, which is T is equals to 4.977. which is it takes approximately 5 days for bismuth 210 to decay half of its original mass. Okay, now let's have another questions. We have a cesium-137 has a half-life is about 13 years. If you begin with 200 milligrams of cesium-137, how much will remain after 13 years? So when it's 0, when the time equals to 0 years, you have the mass is 200 milligram. Well, after 13 years, its half-life is 13 years. So that means after 13 years, the mass should be decayed to 100 milligram. After 60 years, that means it's another 13 years. So you're going to decay half of what you have in 13 years, which is you have 50 milligram, and then another 13 years, which means after 19 years, you will have 25 milligram. So this one is not that hard as long as you make a chart and you realize that, okay, half-life is where the substance mass decays to half, like 50% of what it has originally. Then you will be clear. You don't even need a calculation to help you to calculate that. Okay, so now let's look at another examples. A carbon-14 is a radioactive isotope that present in organic material and is commonly used for dating historical artifact. Carbon-14 has half-life of, so I want to write this down, the half-life is 5,713 years. If a bone fragment is found that contains 20% of its original carbon-14, how old is the bone? Well, to find out how old is the bone, first we need to find out the equation for the decay of the carbon-14. And we know that for the decayed equation, it should be Fx equals to A times 1 minus R to the T, right? Where we know A and the output is going to be 20%, right? So I have 20% of A and then A times 1 minus R to T. But we don't know A can cancel, so we don't need to worry about what exactly the original mass of that fragment. But we don't know R. How do we find T? Well, so our first step should be we need to find the decay rate, right? Well, now they tell you that the half-life tells us that after 5,713 years, half the original substance remains. So maybe we can solve the rate by that, by the half-life. Well, the equation should be set up like half-life 50% of A equals to A times 1 minus R, and it took the substance carbon-14 5,713 years to do that. Okay, so A and A, we both divide 8 on both sides. So I have a 0.5 equals to 1 minus R to 5,713. So here, our unknown variable is not in the exponential. So that means we don't need to use log. In fact, we can just take the root on both sides. We can take 5,713 root on both sides so that I can get rid of the exponential. And then I have 1 minus R equals to that. In fact, I don't need to find out what R exactly. I can just keep it as 1 minus R, because later, when we substitute back into to find out the 20% remaining, we can just keep it as 1 minus R, because that's what the parentheses, so we can save some step. So now, how do we find 1 minus R? Now, here is decimal. We have 0.5, right? So now the roots, how can I write the roots? Well, the root is equal to what? If it's square root, such as square root of A, I know that this is equal to A to the 1/2 power. If it's cubic root, it's equal to A to the 1/3 power. So that means when it comes to 5,713th root, I can write it as 0.5 to the 1 over 5,713 roots. So in decimal, I can write 1 divided by 5730. So that means 1 minus r is equals to 0.9998. I try to keep as many decimal as possible, so that will give me more accurate answer, especially when you calculate that on GeoGebra. So this is equal to 1 minus r. So now we know 1 minus r. Well, we just need to substitute that 1 minus r into this function. Then we will find out, hey, how long does it take for that bone fragment decay to 20%. Okay, so I have 0.28 equals to a times 1 minus r, which is 0.99879 to the t. Well, they both have a, so I can eliminate a by dividing 8 on both sides. Okay, now we have a logarithm function. Earlier, I told you to convert it to exponential function. Now I want to use another way, the second method, which is exponentiate the function on both sides. So let's take ln on both sides. So I have ln 0.2 equals to ln 0.99879 to the t power. And by the exponential rule of logarithm property, I can pull out the t for the front. So I have a ln 0.2 equals to t times ln 0.99879. I should write this in here. Okay, and then I can divide it by ln 0.99879 on both sides to eliminate that. So in decimal, this should be what? ln 0.2 divided by ln 0.999. Oh, I forgot one more 9 in here. A790. I can keep as many as possible because I still keep in the answer from the previous step. So that's why I'm using decimal, because decimal, you will keep all of the step, the previous calculation that you did. All right, so the answer is t is equal to 13,300 years. So that means that bone is 13,300 years. That's very interesting. I really love this application of a logarithm function. All right, so if we have a half time, we also have the opposite, which is double time. So think about it. Half time means how long does it take for the substance to decay to half of its original mass. So what do you think about the definition of double timing? Double timing is how long does it take for the substance to double its mass. So that means originally if you have 100 milligram, how long does it take for you to grow to 200 milligram? Again, they're trying to find the time. So look at this specific example. Now let me clear the decimal. A cancer cell sometimes increase exponentially if a cancer cell growth contained 300 cells last month and 316 cells this month. How long will it take for the number of the cancer cells double? Well, if you think about this question, when we're defining how long does it take, we have to double. Originally, you have 300, right? To double it, I need to have 316. And the function should be 1 plus r, since this is growing. The power should be t. Oh, I'm sorry, should be doubling, should be 600. Okay, but again, we don't know r, or we don't know 1 plus r, right? So how do we know 1 plus r? Well, from the previous sentences, we know that, hey, we are given 2 pieces of data, which means in this month, we're starting with 300, and after 1 month, the cancer cell grows to 360. So this is the information that we know. Well, we can plug in our growth function to find out about our R, the rate, or the 1 plus R. So 360 equals to 300 times 1 plus R to the time, which is 1, because it takes you 1 month. All right. So now 1 easier to calculate. We divided 360 on both sides. So that means 1 plus R is equal to, oh, we divide 300 on both sides. Sorry about that. So that means 1 plus R equals to 13.6 divided by 13, which is 1.2. So the growth rate is 20%. It doesn't matter. We don't need to know R. We just need to know 1 plus R. Okay, so now after we know 1 plus I, we can find out the double timing for that cancer cell. All right, so I have output is 600 equals to 300, and then 1 plus R, which is 1.2 to the t power. We want to solve for t. The first step is you need to divide it by 300 on both sides. I have 2 equals to 1.2 to the t. Well, the unknown variable is in the exponent. You can either convert it to a logarithm function, which is log, the base is 1.2, the base remain the same, and then output become input, input become output. So t should equals that. So in a logarithm function, in a decimal, I can calculate that 2 divided by log 1.2. which is 3.1. It's 3.8. So t is 3.8. Remember, our unit is month. So that means for that cancer, it takes 3.8 months for the number to double. Okay, let's look at our last example about the doubling. Well, a new social network website has been growing exponentially with the number of new members doubling every 5 months. If the site currently have 120,000 users and this trend continues, how many users will the site have in a year? First, we need to find out the rate. Well, I know that it takes 5 months to doubling. I can let the function, the growth function should be fx, the output equals to a times 1 plus r is growth, so that's why it's 1 plus r. 1 plus r to t. And we know that the rate, it takes 5 months to doubling. So that means the output is going to be 2a times a, and then 1 plus r to 5. Simplify it, we divided a on both sides. I have a 2 equals to 1 plus r to the 5th. And then I take the 5th root of 2 on both sides. I got, let's use decimal, 2 to the 1/5 is equals to 1.148698355. I try to keep as accurate as possible, so that would be eliminate my errors, especially when you're doing my open math. If they ask you to keep the 4 decimal places during your calculation, keep to 4 decimal places. Other than that, keep it as detailed as possible. Okay, I know that 1 plus r is equal to 1.148 something, and now they ask you how many years will the site have in a year. Well, so I have the function. I don't know the output. I'm trying to find out the output. Our A is 120,000, and the R is 1.1486933 to the time, 1 year. So that means we are calculating the rate. The growth rate in here is per month because we calculate that by 5 months. So that means in here, instead of 1, we need to put 12 as the exponential. So now we can use the decimal to find out what will be the output after a year. So let me copy these. I believe I can copy these in here to 12 months. So that means your user is going to be 633,364. Since this is user, we always round up because you can't have half human being. Okay, so that's it for the application problem of logarithm and the exponential function. It's very interesting. Let me know if you have other questions.